Section 4.3, Example 2 says the theater club sells a total of 101 tickets to its first play. A student ticket costs $1. An adult ticket costs $2.50. Total ticket sales are $164. How many student tickets are sold? We can start by labeling our variables. We will let X represent the number of student tickets sold and Y represent the number of adult tickets sold. Using the fact that there were 101 tickets sold total, we can add the number of student tickets and the number of adult tickets to get the total. So X plus Y should equal 101. We also know that ticket sales were a total of $164. Every student ticket costs $1, so we'll get 1 times X, the number of tickets sold, for the total of the student tickets. Each adult ticket costs $2.50, so 2.5 times the number of adult tickets, Y, will give us the total for the adult tickets sold. Notice that X has a coefficient of 1 in each equation. We have X with a 1 in front. It's invisible because when it's just 1, we don't have to write it. Here we did write the 1 because we were identifying that it was $1 per student ticket. If we want to have opposite signs, we can make one of these equations have a negative 1x by multiplying the entire equation by negative 1. We can also rewrite equation 2 to have just x plus 2.5y equals 164. If we want to multiply equation 1 by negative 1, we get negative 1 times the entire equation, x plus y equals 101. We're going to distribute this negative 1 to every single term in the equation. So we have negative 1 times x gives us negative x, negative 1 times positive y gives us negative y, and negative 1 times 101 gives us negative 101. Now if we use this new version of equation 1 and our equation 2, we have coefficients of 1 and negative 1 for x, which gives us the same number but opposite signs. So now we can add 1 and 2 straight down. Equation 1 is going to be negative x minus y equals negative 101. Equation 2 is x plus 2.5y equals 164. Adding straight down, we get negative x plus x, which is 0. Negative y plus 2.5y gives us 1.5y. Negative 101 plus 164 gives us 63. Our goal is to get y all by itself. We have 1.5 times y, so we can divide both sides by 1.5 to get 1.5 divided by 1.5 is 1, so we have 1y, or just y. 63 divided by 1.5 gives us 42. A note for that last step is if you don't know that 63 divided by 1.5 just comes out as 42, you can rewrite 1.5 as a fraction. So you can rewrite 1.5 as 3 divided by 2, and then we have 63 divided by 3 over 2, but we can rewrite 63 as 63 over 1, and then we have 63 over 1 divided by 3 over 2, which is dividing two fractions. That is the same as saying 63 over 1 times 2 over 3. You keep the first fraction, change to multiplication, and flip the second fraction. 63 times 2 is 126, 1 times 3 is 3, 126 divided by 3 will give us the 42 that we had over here. Now that we have the y value of 42, we can substitute y equals 42 into either equation, 1 or 2, to solve for x. It doesn't matter which one you use. I think equation 1 looks a little bit more simple, so I'm going to use x plus y equals 101, plug in 42 for my y value to get x plus 42 equals 101. To get x by itself, we can subtract 42 from both sides. 42 minus 42 is 0, so we have just x on the left. 101 minus 42 gives us 59. Therefore, x equals 59. Our goal here was to figure out the number of student tickets sold, which was represented by x. Now that we know that x is 59, we can say there were 59 student tickets sold. In the previous lesson, we did a problem very similar to this, and we chose our strategy specifically so that we would get the value of whatever we needed first. So we didn't actually find both variables in that problem. There is more than one way to solve this problem, and you could figure out a way to get just x first, and then you don't actually have to solve for y. But based on the way these problems were written, it was easier to find the y value and then just plug it in to get the x value. The work for this problem is written out on the next few slides. And it's actually a multiple choice problem on the slides. So in the slides, you would want to end up with the number 59. Keep in mind that they did put 42, which was the other value. So on MathXL, if you did this problem as a multiple choice problem, be careful, make sure you're looking for the right variable. Now I would like you to try number 3 on page 248. Your school's talent show will feature 12 solo acts and 2 ensemble acts. The show will last 90 minutes. The 6 solo performers judged best will give a repeat performance at a second 60-minute show, which will also feature the 2 ensemble acts. Each solo act lasts X minutes, and each ensemble act lasts Y minutes. For Part A, write a system of equations to model the situation, and for Part B, solve the system from Part A. How long is each solo act? How long is each ensemble act?